Dear sales and professors, students and attendants, good afternoon. It is my pleasure to participate in this session and to introduce my speakers, which will present different kind of presentations in the field of risk management and circular economy in African countries. My great welcome for Professor Alhassan Sulemana as co-chair with me. It is now to present the paper. It is titled "Oh, the Youth Observed Liabilities in the Factor of PAX," presented by Amin and Prof. Kwame and Kwame, which had the energy research national research center at my presentation will talk about the results and discussion and area in clinical. About 19.76 million tons solid waste annually contains 4.9 million tons industrial waste. Most of them is and treatment and refining. Plate sites, there are many kinds of plates. There are raising, building plates. According to American C 62, it can classify the building place specification into according to condition to significant conditions, speed and condition and see standard boundaries which are quite this table has shown that the standard specification three the materials of bricks are clay, sand, and rubber. The American bricks have many components and instruments. This results from science by the rubber and bonding. This create the following by the Sulemana and the the bricks, such as ceiling and ceiling tiles, and the The overall plan is the The HIT and consists This is my favorite of green technical base and the person base with different kind and different percentage of course. The green sample finalization, the volume drive treatment, this figure shows the volume drive radius of droplet samples with different percentage and the temperature is for 1% of course. And for the sample characterization, there are these figures show the volume file series absolute for the volume different volume series with different volume addition. And with addition and different pictures. And respective weights. One of this is increasing the weight addition, and another one is increasing and there are some with KJSIM standards. We have IPLA, which is conforming standards. Conventional standards can be very different for the second hand this work is done by the medical service, starting from
A187, efficiency of solid waste collection systems at a municipality in Ghana using data envelopment approach. Claudia.
Good afternoon, everyone. My name is Claudia Efiabuache, an MPhil environmental science student at Kwame Nkrumah University of Science and Technology, and I'm presenting on the efficiency of solid waste collection systems at a municipality in Ghana using data envelopment approach. This is the outline for my presentation. Solid waste management poses several environmental challenges, exerting impact on the quality of the air, water, land, and even ecosystems. Because of the impact of the solid waste generation, it will be very prudent to develop an efficient waste collection system to enable reduce the negative impact of waste on the environment. Hence, efficient waste collection is essential for building sustainable and also healthy communities. To know how efficient a waste collection system is, there is the need to evaluate the system. And one way of determining the efficiency is by employing the data envelopment approach. Data envelopment approach is a data-driven method which is used to assess the performance in converting multiple inputs into multiple outputs. Hence, the efficiency estimates are used to set a benchmark for evaluating the performance in waste collection systems. Solid waste management poses several problems in developing countries where local authorities are under-resourced. Several interventions have also been made towards managing municipal solid waste. However, targets are not met due to inefficiencies and also high associated costs. Inefficient waste collection systems leads to environmental pollution and also increased operational costs. There are several methods of efficiency estimation, which include the data envelopment approach, the stochastic frontal analysis, the econometric approaches, environmental modeling, and so many on. But for the purpose of this study, the data envelopment approach was used. Using the DEA provides an estimate of the municipality's overall cost efficiency. The overall research was to assess the efficiency of solid waste collection system at Swami municipality in the Ashanti region of Ghana. Oh, sorry. So the data was collected for a period of 16 months. Sorry, my slide is not showing. The data was collected for a period of 60 months at some municipality through the auspices of the Waste Management Institution, particularly particularly the Zoom Lion Ghana. Management institution, they use the two main collection systems. The first one is the door-to-door collection system, and also the second one is the communal collection system. The door-to-door collection system involves waste collection services, which is provided directly at the individual households, where the waste is gathered from each resident's doorstep. It offers convenience for residents, but requires more resources. But for the communal, it involves centralized waste collection points with a community where residents deposit their waste. Was analyzed using the DEA version 2.1 software. Okay, so table 1 represents the descriptive statistics of variables for door-to-door collection systems. The N represents the number of periods in which the data was obtained. That is over 16 months period. And table 2 represents descriptive statistics of variables for communal collection system. Similar thing was done within a period of 16 months. But here, taking a critical look at it, you realize that repairs and maintenance cost and also the cost of labor, there was a very high cost associated with the door-to-door collection system as compared to the communal collection system. The high cost associated implies that there is a very high cost associated in managing municipal solid waste in Ghana. Figure 2 represents efficiencies of door-to-door collection systems. And here, the minimum efficiency was obtained 8.6%, and also the maximum efficiency was 98.7% in March 2021. But the mean efficiency was 83.1 plus or minus the standard error, which is the 0.04. For figure 3 also represents the efficiency of communal collection system. And the minimum efficiency was obtained in April 2021 with 31.7%, and also the maximum efficiency was also 98.2%, which was obtained in March 2020 with the mean efficiencies, which was 81.2 plus or minus the standard error, which was 0.05. But here, the trend indicates that there was a decreasing trend from January 2020 throughout to June 2020, and also it increased a little bit, and also it decreased from January 2021 throughout to April 2021. So in conclusion, the efficiency of solid waste collection systems within the Swami municipality was assessed, and here the door-to-door collection system was found out to be more efficient than the communal collection system. And also, although the two systems were not fully cost efficient, the door-to-door collection system rather exhibited higher cost efficiency than the communal collection system. The findings contributed to the establishment of a benchmark against which the performance of waste collection systems can be assessed. These are my list of references. Thank you very much.
Thank you so much, ma'am, for your presentation. Next up, we have A185, Awareness, Knowledge, Attitude and Practices for Sustainable Market Waste Management, a Developing Country Evidence Review by Jonas Bill, Alhassan Sulemana, Bernard from Ghana. Do we have you online in the meeting? A185.
Good afternoon. I am Jonas Bill, presenting on the awareness, knowledge, attitude, and practices for sustainable market waste management, a developing country evidence review. This is my presentation outline. A lot of studies have been conducted on the awareness, knowledge, attitude, and practices, focusing on households, industries, and communities, limiting data on markets. A search in the Science Direct databases from 2004 to 2023 reviewed 48 review papers in this area. However, none of the studies reviewed considered the awareness, knowledge, attitude, and practices, that is ACAP, of market traders towards solid waste management in developing countries. The review will provide governmental organizations, waste management institutions with solid waste management data, that is on ACAP, which will help them to implement programs and schemes aimed at improving market waste management in developing countries. And hence, the aim of this research is to review the ACAP of market traders for sustainable market waste management in developing countries. Articles between 2005 and 2022 were the inclusion criteria used. Ghana, Nigeria, Ethiopia, Kenya, Nkrumah used in this study were classified as developing countries since they had a human development index of less than 0.800. Table 1 presents the studies analyzed or used in this study. Knowledge, attitude, and practices variables constituted 43% of all the variables, with 40% of the knowledge and attitude practices variables coming from Nigeria, followed by Ghana with 27%. Table 2 also presents the objectives and key findings from the review. ADO 2024, for instance, investigated the knowledge, attitude, and practices of 150 market women in the Takrade market circle, that's Ghana, and reported a high knowledge and attitude but low practices towards waste management, with a gap in knowledge on waste reduction. The findings of the review highlights a close position on knowledge, that is, high knowledge or moderate knowledge by traders towards waste management. And several studies supported these findings. For example, Abdullah and Tunali 2014, Adioli and Enesi, all in Nigeria, and then in China, and then in Malaysia, they all reported low knowledge in Nigeria. High knowledge was also reported in Malaysia, Ethiopia, and Bangladesh, and then Nepal, which were consistent with the finding of this study. An opposite position, however, was found when it comes to awareness. That is, a high awareness or low awareness by market traders towards waste management. High solid waste management awareness were reported in India, Malaysia, Nigeria, and then Philippines. However, other studies in Nigeria also reported a low solid waste management awareness in these. All these supports the findings of the review, that is, a high awareness or a low awareness by the market traders. The findings of this review also reviewed a high attitude by market traders towards waste management. Numerous studies in Nigeria alone support these findings, as well as other studies from the Philippines, Indonesia, then Kenya, and then Turkey all support these findings. Other studies in Ghana by, for example, Aduku 2014 and Kumasi 2017, however, reported low attitudes towards waste management. Market traders had a low practices towards waste management, and this was not consistent with the findings of Magida and then Oresion 2018 in the Philippines, and then Pagasians, who also reported good practices concerning separation and reduction in the Philippines. However, this was consistent with the findings of Nekek 2014, who reported poor waste management practices in South Africa. Radio, television, newspaper, market association were the commonest sources of waste management information. Open trucks and wheelbarrows were the major modes of waste transport to the final dump site, and collection of waste was done weekly. Majority did not practice waste segregation and mostly engaged in open dumping, and this is consistent with the findings of Obelian 2018. Ratio of skips to traders was 1:18, and that of beans to traders was 1:100. There was no significant relationship between age and practice, gender and practice, religion and then practice. However, Almasi et al. 2019 reported a significant relationship between the knowledge, attitude, and practices with that of age and then occupation. Conflicting significant relationships have been reported by numerous studies between the knowledge, attitude, and practices, which is consistent with the findings of this review. For instance, Iwu Ita 2016 in this review reported a significant relationship between knowledge and attitude and practices of traders. However, Hoto 2017 was not significant. Agbefe Ita 2019 reported a significant relationship between age and awareness of market traders. However, in Nyampadu Ita 2020 was not significant. Again, Nyampadu Ita 2020 reported a significant relationship between educational level and then awareness of market traders, but that by Agbefe Ita 2019 was not significant. Hoto 2017 reported a significant relationship between age and knowledge, but that of Adu 2014 was not significant. Hoto 2017 again reported a significant relationship between age and education, but that of Adu 2014 was not. Adu 2014 also reported a significant relationship between the educational level of market traders with the attitude, but that of Hoto 2017 was not significant. And finally, Hoto 2017 reported a significant relationship between the gender and attitude of market traders, but that by Safuedu 2019 was not significant. The opposable high or low awareness will contribute to indiscriminate waste disposal practices, which will undermine waste management efforts by government and waste management institutions in developing countries. There's also a huge gap in knowledge and attitude in terms of practice among market traders in developing countries. Sustainable environmental education should be integrated into markets, considering peers of planning, community-based approach, and circular economy in order to bridge the knowledge gap in waste management in developing countries. These are my references. Thank you.
Thank you so much, sir, for the presentation. Next up, we have A125, determination of the characteristic of bio-oil from the pyrolysis of lemon peel waste. Samira Abidi.
Yes, I am here.
Yeah, we will be giving you the co-host rights. You can share your screen.
Okay. Hello, everyone. I am Samira Abidi from Tunisia. I am very honored to be here today to present my work intituled Determination of the Characteristic of Bio-oil from the Pyrolysis of Lemon Peel Waste. About 92 billion tons of citrus is produced throughout the world. As most of agro-industrial activities in the citrus conversion sector leads to the generation of large quantities of organic waste, it is estimated that about 14–16% of citrus is converted to organic waste. The chemical composition of lemon peel waste reveals a significant content of pectin in addition to cellulose, hemicellulose, and lignin as major compounds. These lignocellulosic wastes could be considered as attractive feedstock to produce renewable fuels and innovative products like biofertilizer and bioactive molecules. The principal objective to explore, firstly, the pyrolysis of lemon peel waste into innovative pyrolytic products having potential application not only in energy, but also in agriculture and the food industries. Another aim was to extract organic compounds from the raw and the bio-oil and to quantify their antimicrobial activity against gram-positive bacteria like Bacillus, Staphylococcus, Enterococcus, Micrococcus, and Listeria, and gram-negative bacteria like Salmonella, Escherichia coli, and Pseudomonas. The freshly processed lemon peel waste was oven dried for 48 hours at 16 degrees Celsius to reduce the moisture. The pyrolysis experiment of dried lemon peel waste were carried using a laboratory scale fixed bed reactor at final temperatures of 300, 400, and 500 degrees Celsius with a heating rate of 10 degrees Celsius per minute. We obtained three fractions: the syngas, the biochar, and the bio-oil. In this work, I will present the characteristic of the bio-oil. Our pyrolysis process made up of pyrolysis reactor, which can contain 7 kilograms of solid waste, and its final temperature is around 800 degrees Celsius. The second is the cryostat provide the circulation of cold liquid to the refrigerant in order to cool the pyrolysis vapors. And the recovery valve for recovery to condensate fraction or the liquid, it can contain the 500 milliliters of liquid. So the purification system used for cleaning the combustible gas and reducing the amount of tars. Finally, the gas analyzer to detect and record the non-condensable gas and low heating value. Let's move now the methods of characterization of raw material and the bio-oil. We have utilized the proximate and ultimate analysis. Next, the GCMS. So the FTI spectroscopy. Finally, determination of minimum inhibitory and minimum bactericidal concentration. The high volatile matter content in the studied lemon peel waste sample reveals its suitability as raw material for pyrolysis process, and the high content of organic matter as carbon and hydrogen makes lemon peel waste suitable for biofuel production. According to FTI results, the studied lemon peel waste is very rich in oxygenated aliphatic and aromatic compounds. The yields of bio-oil obtained at 300 degrees Celsius is about 6%, and at 400 degrees Celsius is about 16%, and at 500 degrees Celsius is about 14% from lemon peel waste at heating rate of 10 degrees Celsius per minute. The bio-oil is mainly composed of alcohol, the carboxylic acids, phenols, fatty acids, aldehyde, nitrogenous compounds, which are a consequence of the features of the compound in the pectin, hemicellulose, cellulose, and lignin contained in lemon peel waste. About the minimum inhibitory concentration and the minimum bactericidal concentration, the bio-oil produced at 500 degrees Celsius was the most active bio-oil against the 8 microbial strains investigated, with the minimum bactericidal concentration from 12 and 25 to 10 to 100 milligrams per milliliter. In conclusion, the maximum yields of bio-oil was 16% were obtained at 400 degrees Celsius. The produced bio-oil is composed namely of phenol, acids, terpenes, alcohol, and nitrogen compounds. Lemon peel waste could be processed to obtain bio-oil and biochar containing active biomolecule with high added value as antimicrobial agents. Bio-oil obtained at 500 degrees Celsius showed the most interesting bactericidal activity against selected foodborne and spawning bacteria. This interesting finding further promotes the use of lemon peel waste pyrolysis bio-oil extracted as eco-friendly alternative to replace conventional antibacterial agents. you for attention.
Thank you so much, ma'am. Next up, we have A123, influence of chemical pre-treatments on the morphological and the structural properties of Rosa centifolia fibers. Fatma Bihiri.
Yes, I'm here.
Yeah. Hello, ma'am.
I'm trying to share my screen.
Yes. We'll be giving you the co-host right.
Good afternoon, everyone. I am Fatma Bihiri from Tunisia. I am a researcher at the Research and Energy Technology Center of Boursadria, and I am a member of the Laboratory of Wind Energy Management and Waste Energy Recovery. I have a great pleasure today to attend the 13th International Conference on Sustainable Waste Management and Circular Economy, and to share with you our work dealing with the influence of chemical pretreatments on the morphological and structural properties of Rosa centifolia fibers. My presentation will consist of a brief introduction, a description of the methods used in this work, followed by the main results and some conclusions. Let's start with the introduction section. As everyone knows, concerns about climate change caused by greenhouse gas emissions from fossil fuels, the potential increase in demand for transportation fuels, and the depletion of petroleum resources have sparked interest in sustainable biofuels and biochemicals made from renewable resources like lignocellulosic wastes. Lignocellulosic wastes have been recognized as abundant, sustainable, and environmentally friendly resources that can be converted into fermentable sugars for liquid fuels. Bioethanol, one type of biofuel, can be produced in two steps: enzymatic or chemical hydrolysis of cellulose and fermentation of sugars by microbial organisms. However, it is critical to note that the structure of lignocellulosic biomasses is complex and highly recalcitrant to hydrolysis. Therefore, a pretreatment step is required to disrupt the complex structure of this biomass and increase accessibility to cellulose. Pretreatments can take several forms: chemical, biological, mechanical, thermochemical, or even a combination of two or more types of pretreatments. Following pretreatment and enzymatic hydrolysis is the fermentation step, which aims to employ the recovered sugars and convert them into bioethanol. Finally, the inclusion of a distillation step allows the separation of the alcohol from the fermentation mixture and the recovery of pure ethanol. In Tunisia, the process of hydrodistillation of medicinal and aromatic plants, in particular roses, produces around 600 tons of rose water per year, generating more than 2,000 tons of lignocellulosic residues in the form of roots, fruits, seeds, leaves, and flowers. These wastes are little exploited and are in most cases thrown in nature or incinerated, causing environmental issues. Among the medicinal and aromatic plants, Rosa centifolia represents a group of roses belonging to the Rosaceae family and originating from Asia, Europe, North America, and Northwest Africa. In addition to its ornamental aspects, this rose is one of the important medicinal and aromatic plants with multiple uses. The most common exploitation is the extraction of essential oils and rose water by hydrodistillation and their application in the food, cosmetics, and pharmaceutical fields. However, despite being abundant, readily available bioresources and having multiple applications, the hydrodistilled residues of Rosa centifolia have never been the subject of bioethanol production. In this regard, the purpose of this work was to investigate for the first time the valorization of these unfamiliar wastes as potential sources for the production of bioethanol. To achieve this goal, a study on the influence of chemical pretreatments on the morphological and structural properties of these wastes was conducted by colorimetric, microscopic, and spectroscopic techniques. Before starting any treatment, a chemical analysis of the raw material was performed. As lignocellulosic biomass, the roses consist of three main elements: cellulose, hemicelluloses, and lignin, with 32% cellulose, 26% hemicelluloses, and more than 22% lignin. Beside this, there are 27% of hot water soluble polysaccharides. According to these results, cellulose is surrounded by huge amounts of lignin, hemicelluloses, and other polysaccharides, which require efficient pretreatments for their dissolution. In this work, combined treatments were performed. The wastes were first sun-dried and ground. The dried powder was dewaxed with a mixture of ethanol and toluene for 6 hours, then treated with hot water. The residues were subsequently subjected to an alkaline treatment with a sodium hydroxide solution for 12 hours at room temperature, followed by a bleaching step with a sodium chloride solution at 80 degrees Celsius for 4 hours. After the performed treatments, a notable reduction in the non-cellulosic amounts was remarked. In fact, almost all of the hot water soluble polysaccharides were completely solubilized and after these treatments. In addition, about 78% of the hemicelluloses and 81% of the lignin were removed after the chemical treatments. Accordingly, the content of cellulose in the recovered material increased from 32% before the treatments to 78.21% at the end of the bleaching process. Here are some photos showing the appearance and color of the cellulosic materials before and after the bleaching step. As you can see, white color cellulose having a good whiteness index was recovered after all these treatments. The influence of the different treatments on the fiber morphology was evaluated using microscopic studies. As shown by the scanning electron microscopy examination, the starting sample is composed of microfibers of about 200 micrometer in diameter with a rough surface. After the alkaline and bleaching processes, we observed the destruction of the fiber structure and the complete defibrillation into microfibers of about 12 micrometer in diameter, having a smooth and clean surface. The thickness of the bleached fibers was found to be smaller compared to the untreated waste, indicating the elimination of the other non-cellulosic compounds. In addition, an improvement in the specific surface area was observed following the action of the chemical treatments. The increase in the surface area of the biomass should improve the accessibility of enzymes or acids to the cellulosic polymer and possibly allow faster and more efficient digestibility. Let's see now the effects of the chemical treatments on the fiber structure using FTIR analysis. The spectra of the studied samples are shown on this slide. we found that the untreated and treated samples displayed some common chemical groups. However, some differences were detected. In fact, in the case of the extracted cellulose, I mean the bleached fibers, we remarked a significant reduction in the height of the peak located at 1736 centimeter minus 1, and the complete disappearance of the peaks located at 1515 and 1246 centimeter minus 1, which are assigned to the chemical groups involved in lignin and hemicellulose structure. The effect of the performance treatments were also studied by X-ray diffraction study, as shown on this.
Excuse me, ma'am. Fatma ma'am.
Yes.
Your time is over for the paper presentation. Can you conclude your presentation in few sentences?
Yeah. 1 minute, just 1 minute, okay?
Okay, ma'am, just 1 minute because we are.
As I have said, the effect of the chemical treatments was also studied by X-ray diffraction study, and as shown by this slide, the samples showed a typical structure of cellulose form 1 with 4 peaks at approximately 14, 16, 21, and 34 degrees corresponding to the crystalline zone. We remarked also that the peak at about 22 degrees became sharper and its intensity increased after the chemical treatments. Consequently, the crystallinity index increased from 29% for the untreated waste to 56% for the bleached fibers, indicating the elimination of the non-cellulosic components. To conclude, this study demonstrated that the chemical treatments were effective in eliminating the undesired organic components from the untreated roses fiber surface. After the chemical pretreatments, a cellulose-rich material presenting a high whiteness index, good purity, and moderate crystallinity was recovered. The obtained cellulose-rich fraction is suitable for the recovery of simple sugars and their transformation into bioethanol. And finally, the valorization of these inexpensive and affordable residues will not only solve the environmental issues, but also offer attractive and sustainable feedstock for energy recovery. I finished, and thank you all for your time.
Samira ma'am, we will take the question and answers at the end of all the presentations. And to remind, before starting with the next presentation, the time limit is of 10 minutes for each paper presentation. You will be reminded once the time is over. Starting with the next, A19, physiochemical analysis of leachate from municipal solid waste landfills in Ilorin Metropolis, Kwara State, Nigeria, by Amin Babatunde. Is A19 present in the meeting? A19, physico-chemical analysis of leachate from municipal solid waste.
Good evening, everyone. Do you see my presentation?
Yes, we can see your presentation.
Okay, I am Muad Baalek, a PhD student in the Faculty of Science of Tunis Al Manar and the Center of Research and Energy Technology. I would like to thank you for being here and for your attention to my presentation today. I'm very honored to be present between you guys. Today, I will present the main results of my research on the subject of the valorization of bio-waste and bio-based products based on compost and biochar that can be used as biofertilizers. To begin with, this work has 4 parts. We start with an introduction where I will present the framework of our subject, then a part to present the methodology of this work, where we present the process of composting and pyrolysis. In the next step, I will present the analysis while discussing their results, and we will end with this presentation with a conclusion. The management of household and similar waste has become a major issue, with millions of tons of waste generated each year on an international scale, despite the recommendation and regulatory measures aimed at reducing the production of waste at the source and the quantities of final waste by promoting sorting, recycling, and incineration. Thus, landfilling remains the fate of a significant part of waste. In Tunisia, organic matter makes up 2/3 of household waste, or even 68%, landfilled without treatment. Their decomposition generates a large quantity of leachate and biogas, as well as nuisance such as other nuisance. After treatment, the volume and mass of this waste to be landfilled can be reduced between 40 and 60%. The organic fraction existing in the waste has a specific characteristics, which is biodegradability. The origins of the deposit of household and similar organic waste are numerous. Private exploitation and the public domain produce flows of very different natures, quantities, and qualities depending on the origin. To address this problem of excessive increase in the quantities of municipal waste, new recovery channels are needed. Recovery, either material or thermal, consisting of converting waste into reusable products, is considered a viable solution in Tunisia. Our work examines the feasibility of producing compost and biochar from household waste for later use as biofertilizers. The work includes, on one hand, a comparison of 3 composting methods: conventional composting, composting by efficient microorganisms, EM, and bokashi composting, and on the other hand, biochar produced under 4 different temperatures. This work is carried out in collaboration between the Center for Research and Energy Technologies, under the supervision of Mrs. Aida Trabilsi, and the municipality of La Marsa. Passing to our work, in this section we present the composting process with its 3 methods, the steps followed for the production of compost and its benefits, and then the pyrolysis process. Thus, the composting process can be defined as the change in state of organic matter into a stable, sanitized, humus-rich product. Decomposition here is aerobic. So, compost is the result of complex microbiological activity. This technique must allow sufficient microorganisms to develop to digest the substrate. As we can see here in the picture, this bacterial life is conditioned by the amount of oxygen, humidity, temperature, and physicochemical characteristics of the material to be composed. Hence, the importance of monitoring these physicochemical parameters during the process. The experimental setup corresponds to a trial in the form of aerated windrows for the first 2 treatments, conventional composting and EM composting, in the shade, and in a closed bokashi tank for the 3rd treatment. Here we have 2 types of organic waste that we used: the household waste, such as raw and cooked kitchen scraps, leftovers, market waste, peelings, coffee grounds, eggshells, and the green waste, which is pruning waste from private and public gardens, wilted flowers, and plants. After the waste has been collected, it is sorted and homogenized by mixing different types and then swabbed. After homogenization, the mixture is divided between a classic swath, where it will undergo aeration only, which is the classic swath, It was mixed with EM product. This is a mixture of microorganism, bacteria, algae, and fungi, and a bokashi tank where it will undergo anaerobic fermentation. Adding compost helps to correct the soil organic matter deficit. Here we feed the soil before we feed the plant. Compost has many benefits such as increasing the resistance to wind and water erosion. It increases also the root respiration thanks to better soil structure. It stimulates the growth, increase dry material yield, and provides a source of various nutritions, such as major elements and trace elements. Passing to pyrolysis, it is a process of thermal recovery of biomass that is carried out in an inert atmosphere and the absence of oxygen and other oxidants to produce non-condensable gases and condensable vapors, which is the bio-oil, and a solid residue, which is the coal. Its varying properties depending on the operating conditions and which can be recovered at different levels. So in our pyrolysis experiment here, we performed 12 pyrolysis tests, 3 tests for each temperature at different maximum heating temperatures, 300, 400, and 500 and 600 degrees in order to determine the effect of temperature variation on both the mass yield and the quality of the solid residue produced during pyrolysis. The protocol used was sampling preparation for pyrolysis, putting the samples in oven for 1 hour, cooling the biochar, and measurements of the waste of the dry residue. Here we have the benefits of the biochar, which like carbon sequestration, it improves the soil structure. It also improves the water holding capacity and reduces the greenhouse gases. When working, analysis of compost and biochar production methods were conducted with the aim of maximizing the quality of the final product. The variation of temperature, pH, and humidity during the composting process was studied for the 2 composts, conventional and EM compost. For bokashi, this control was not necessary since this method is anaerobic fermentation, so the absence of biochemical reactions leading to the elevation of temperature or other parameters. In the laboratory, analysis of dry matter, dry volatile matter, ash content, and even infrared spectroscopy analysis were carried out on several samples in order to determine their physicochemical properties. Here, the temperature curve coincides with the curves studied in the theoretical part. Thus, the maximum temperature is 67 degrees for EM compost. This value remains below 70 degrees, which is the temperature where there is destruction of living organisms. On the other hand, it only reached 56 degrees for the classic compost. The temperature remains close to 50 degrees for 15 days for EM compost and only for 5 days for the classic compost, thus representing a clear difference between these 2 methods. For the pH, has a slight non-significant difference with a maximum of value of 8.5 for conventional compost and 8.3 for EM compost. For the humidity, it seems that to be the parameter with the greatest influence. It is optimal, varying between 40 and 50% at the end of the composting process.
You, ma'am, but your time is over. 10 minutes for your paper presentation. Can you conclude your presentation in a minute?
Yes, of course. We will move to the final results. Here we have the comparison of conventional and EM compost and bokashi. We see here that the bokashi is the most efficient composting method. That's it has no turning required, no watering required. It is very fast. It nearly has 1 month to reach maturation. That and the least wanted composting method is the conventional composting, which EM composting is more likable to use here. These results show also that the composting and pyrolysis techniques are effective in terms of bio-waste recovery, with an optimal biochar yield for 35% at 300 degrees, and the compost yield varying between 45% for conventional compost and 80% for EM compost. To conclude, product characterization show that there is a strong possibility to use biochar and compost as soil amendments. To complete this work in the future, it is necessary to master the bokashi test and to improve the yield of biochar at a temperature of 300 degrees. It would also be interesting to conduct further studies to test complex interactions between biochar compost in the soil. And thank you for your attention. I'm sorry I was so late.
Thank you, ma'am. With the last presentation of the day, A126, biochar production from tannery fleshing waste by fast and slow pyrolysis by R. Chakmi. A126, are you present in the meeting?
Yes, I am present. I will share my presentation.
Yeah, we will be giving you the co-host rights. You can share your presentation. Yes. Your presentation is visible. You can start.
It's okay. First of all, I will introduce myself. I'm Rawia Shagmi, doctor at the Research and Technology Center of Borsadria. I will present you today the main results of my work entitled Biochar Production from Tannery Fleshing Waste by Fast and Slow Pyrolysis. Usually, 75 to 80% of raw hides or skins are discarded as solid waste when they are processed into finished leather. And tanned solid waste, raw trimming and fleshing account for around 400 kg per tons of raw hides or skin processing, of which fleshing contributing for around 230 kg. The objective of this study is to convert tannery fleshing waste into precious biochar by slow and fast pyrolysis. Moving now to materials and methods used in this study. This study is done in 4 steps. First, collecting the biomass from tannery manufactory, then their pre-treatment by drying, sieving, and grinding, then their characterization using several methods, such as proximate, ultimate, mineral composition, thermogravimetric analysis, and FTR and XRD analysis. Moving now to the pyrolysis experiments. For the slow pyrolysis, we used a fixed bed reactor at 500 degrees Celsius as a final temperature, 10 degrees Celsius per minute as a heating rate, and 1 hour as a residence time. For the fast pyrolysis, we used a conical spouted bed reactor at 500 degrees Celsius as a final temperature, 25 degrees Celsius per minute as a heating rate, and 25 minutes as a residence time. The produced biochars were characterized using proximate, ultimate, and FTR and XRD analysis. Moving now to results and discussions. the high organic contents of the tunnel refreshing waste biomass, which indicate their suitability for energy recovery. The tunnel refreshing waste is very rich with inorganic elements, mainly calcium, silicium, sodium, and sulfur, affects the pyrolysis reactions and the final product's qualities. The presence of minerals in the tunnel refreshing waste is due to the addition of chemicals, sodium chloride, sodium sulfide, and lime for rawhide curing and enhancing treatment in beam house operations. For the thermogravimetric behavior of the tunnel refreshing waste biomass, it can be seen 3 zones of degradation. The first is related to the moisture release, the second for the volatilization phase, and the third for the degradation of calcium carbonate and some complex proteins. For the biomass FTR and XRD spectra results, it can be seen that the presence of aromatic aliphatic carbonates and oxygenated structure which confirms the organic nature of the studied biomass. The mineral species in the tunnel refreshing waste sample came from the tannery industrial process, which uses salts for the rawhides preservation, alkaline solution to remove fats as well as keratin, sulfur to remove hair from the hides. Moving now to the pyrolytic results. For the pyrolytic biochar yields, it can be seen that the maximum biochar yield is obtained by slow pyrolysis with around 48%. For the main characteristics of the derived biochars, it can be seen that slow pyrolysis produces a biochar with high elemental carbon and low H contents. The fast pyrolysis produces a biochar with low elemental carbon and high H contents. For the produced biochars FTR results, it can be seen that there is a decrease in all biochar functions groups due to the thermal degradation of main components due to the enhanced degradation in conical spouted bed reactor. From the XRD patterns, it can be seen that compared to slow pyrolysis, the produced biochars by fast pyrolysis present the same mineral peaks, except for silica peaks observed for ternary fleshing waste biochars. The occurrence of silica peaks in the fast pyrolysis produced biochars is related to the conical spouted bed reactor, which uses sand as fluidizing agent, which is clogged with ternary fleshing waste biochars. As a conclusion, the tunnel refreshing waste are converted into sustainable pyrolytic products. Slow pyrolysis lead to the production of maximum biochar yield with around 48% versus 45% by fast pyrolysis. The mineral H in biomass is considered as an important factor influencing the pyrolysis process, in particular the yields and composition of the pyrolytic products. The biochars produced from tunnel refreshing waste are rich with alkali earth metals, which encourage their uses for amendment and dye removal. This work showed the potential of thermally treated tunnel refreshing waste as eco-friendly and cheap for biochar production with high quality as well as respecting the environment. This study gives results that could be completed through further investigations and perspectives in order to commercialize biochar concerning more detailed characterization of the produced can conclude their specific applications, investigate the potential of biochar as an adsorbent for dyes, pesticides, and for organic pollutants, the physical and chemical activation of biochars in order to improve their surface area. Thank you for your attention.
Session. We had one question. We had one question for R. Chakni. Could you please explain the pyrolysis conditions? It was done. R. Chakni. Are you there in the meeting? Moving forward for Dr. Fatma Bihiri. Dr. Fatma Bihiri, are you present in the meeting?
Yes, I'm here.
Yes.
Sorry, I am Rawia Shakmi, and the question is for Waad.
Okay. Is Ward present in the meeting? Dr. Fatma Bihiri will move to your question.
Yeah, okay.
How do you calculate the Christian?
I am present here. Waad is here.
Ma'am, we'll take your question later.
Okay.
The question for Dr. Fatma Bihiri, how do you calculate the crystallinity index and who's the crystalline form or obtained cellulose?
Okay. We calculated the index of crystallinity using the equation of Siegel, which takes into account the maximum intensity peak of the crystalline region at about 22 degrees and the height of the minimum intensity of the amorphous region located approximately at 18 degrees. For the second question, it was about the crystal forms. That's it?
Yeah, what's the crystalline form of the obtained cellulose?
Okay. There are 4 different polymers of cellulose. Cellulose form 1, 2, 3, and 4. And the native form is cellulose form 1, which can be found in nature. The other forms can be synthesized after chemical treatments. In this work, we obtained a cellulosic polymer which displays the form 1 of cellulose. And
Okay.
the form 1 beta, which is specific for higher plants.
Okay, thank you so much.
Thank you.
The question for Ward. Could you please explain me the pyrolysis conditions? It was done under inert atmosphere.
For the pyrolysis, the main condition for pyrolysis is to be in an inert atmosphere where we have absence of oxygen and the other oxidants. So, replying to Rawia, yes, the pyrolysis was in an inert atmosphere.
Okay, thank you so much, ma'am. Ma'am, do you have any questions? Okay, thank you so much, everyone. We would request everyone to please turn on your cameras. We would like to take a group photo.